when we take the transfer function, so we're dividing the output of the black box with the input of the black box, and we see that this is the curve that we obtain when we plot this transfer function. By analyzing here, we see these ripples in the pass band. It looks like a high pass, so it's cutting until around 8 kilohertz. It has these ripples, and it's at 800 hertz. It's already on minus 80, minus 78. We see here there is a roll-off that is more than 60 dB, but less than 80 dB. Perhaps this would indicate that it's a third order filter. And if you remember analog filters, the Chebyshev filter has these characteristics of ripples in the pass band and a steeper roll-off in the cut region that's more than the Butterworth filter. And if we compare with a Chebyshev filter type 1, so I'm constructing here a Chebyshev with third order with 3 dB in the allowance in the pass band as a ripple, 8 kilohertz cutoff frequency, and I'm also comparing with the Butterworth filter just so we can have an idea. So we see that the black box and the Chebyshev third order type 1 filter, they are very close to each other, so it could be a very good approximation. So we have much more attenuation in the Chebyshev, even if the same order as the Butterworth filter. If we take the inverse Fourier transform of our black box, we will have our impulse response of the filter, and again I expect it to be a truncated version of the impulse response of a Chebyshev filter. I also constructed this black box this way, so when we plot the impulse response and the black box, we see that they match. So indeed we have achieved our purpose of identifying the system using frequency response calculated using a sinusoid, sweeping sinusoid. So it's the same technique we used before, but with a different input signal. If you're interested in these techniques, I leave here a video that I took part in the MATLAB context 5 years ago. So I implemented a dual channel FFT audio analyzer. So it's based in this principle of transfer function, and I give a small demonstration in this video. And these techniques, they are used in many professional audio analyzers. So we have from Meyer Sound, the SIM3 audio analyzer. They use it to align sound systems. We have Smart, and we have many others, other manufacturers that are offering this kind of transfer function audio analyzers.